Today's AIM Kipsters will be able to rotate points or figures on a coordinate grid. So we're going to be looking at rotating points on a coordinate grid that works along our unit. We've talked about several other transformations already. Translations, that SL, we're reminding us that translation means to just slide it around. The reflections, that FL, reminding us that's just kind of our flipping it over the various different axes. Rotations is going to be a little bit different, a little bit more complicated in terms of being able to actually visualize where the figure should go. So instead of immediately going ahead and visualizing where it is, I'm going to write down my original points so I can use that here in a second. My A is 2, 1, my B is 3, negative 6, and my C is 5, negative 2. And what I'm going to do is I'm actually going to physically rotate. Now this asks me to rotate at 90 degrees clockwise. So what does that mean, clockwise? That means we're rotating it in the same direction that a clock would go. And as most of us look at a clock, we say that it rotates to the right. So I'm going to take this, and I'm going to rotate my figure 90 degrees in the direction of the clock. So I'm turning it as I see the clock turn. And this is actually going to tell me physically where my new points are. So I can see what this looks like is it looks like it's now at negative 1, negative 2. Negative 1, negative 2. And as I look at my B, it now looks like it's at negative 6, negative 3. Negative 6, negative 3, and my C looks like it's now at negative 2, negative 5. So negative 2, negative 5. So I'm going to go ahead and turn this back and re-upright my figure. And now I can go ahead and graph these 3 points so I can see what it would look like after I've plotted it. So I've got my A prime, I'm saying should be at negative 1, negative 2. Negative 6, negative 3. That's my B prime. This was my A prime. And my C prime is at negative 2, negative 5, negative 2, negative 5. What we can see is it looks like this is the same figure, it's just been rotated. And if we go back and we look at it, that clockwise rotation, we're expecting it to look the same. Yes, that seems to look the same. So what is the rule here? Well, when we look at this, we see the rule here is that we see that our values seem to be switching. Our 2 comes over here, our 1 comes over here. So when we describe this, we're going to say, all right, we started with x and y, and we can see that for our prime values, that they are going to switch. But we also see one other thing happening. When we look at this, we see that while the negative 1 stay negative 1, the negative 6 stays negative 6, negative 2 stays negative 2, and all those, in other words, all those y's stay exactly the same. We see that as the x transitions over to the other side, changes side, it also switches its sign. So it goes from a positive to a negative in these particular cases. Okay. So we're going to put onto that value that we're going to, as the x changes, it's going to become the opposite of the x. And that doesn't mean that it's going to become negative. That means that it's switching its sign. If it's positive, it's going to become negative. If it's negative, it's going to become positive. So the question is, can we memorize this rule? Well, absolutely there are some people who can memorize it, but most people can't. If you can memorize it, you might be able to memorize it, and when we flip over the page and you work on more problems, you might remember what it is. Or when you get back tomorrow, you might know what it is. But I can almost guarantee you that a week down the road, a year down the road, 3 years down the road, and when you get to geometry class and you need this information, you're not going to be able to remember that rule. Personally, I can't remember it from one problem to the next. So There's got to be, we're going to have to find a way. It's going to get even more complicated when we start adding in counterclockwise rotation, which means we're moving in the opposite direction, because this is going to have a different rule. All right, so it's the same thing. I see my points for this problem are all in the same place. I have 2, -1. I have my B is 3, -6, and C is 5, -2. And this time when I rotate it though, I'm going to be rotating it the opposite direction, the opposite way that we would see the clock. So when it's rotated, it's going to show me where my points look like they should be. So here we have 1, 2, and 2, 5 for C. And my B is 6, 3. 6, 3. And so as I rotate it back, and I go ahead and I graph those points, we're going to see that it has swung itself up here. This is my A prime, and my B prime at 6, 3. And my C prime at 2, 5. And we can see again, same figure, it's just been turned this time, all right? And so that's kind of what our rotation is all about. And so again, we can kind of see a rule happening here, but when we look at the rule, it's a little bit different. The X's and Y's are still switching. But what we can see is that in this particular case, it's the Y value that seems to be changing its sign, and the X values are staying the same. So this is going to be a -Y over here, the opposite of the Y. As you can see, the opposite here, these are now changing from negatives to positives, and so it's just the opposite of whatever it is already given to you. So what's the difference between the two? We can see the difference between the two is which number we are switching the sign of, either the X as we're moving it or the Y as we're moving it. And personally, like I said, I would never remember this. I wouldn't remember it for the next problem. So we have to figure out a way to sort it out. So the way that we can do that is we can just pick any one point. It only takes one point to remember the rule. And just pick that one point. Here I'm going to pick 8, 1. And then I'm going to, for a clockwise rotation, I'm going to go ahead and turn it clockwise. And I'm going to see where it is. And I can see where it is now is at 1, -8. And as I switch it back, that just quickly can remind me that, all right, my X and Y are switching, and as my X comes over here, it becomes negative. Okay? We can do the same thing with a clockwise rotation. You can see that only takes 15, 20, 30 seconds. So with a clockwise rotation, or a counterclockwise rotation, I'll do the same thing. I'm just going to graph the same point, 8, 1. And I'm going to go ahead and turn it for myself so I can see what that's going to look like. So I'm moving counterclockwise, and I can see that that point is going to be at -1, 8. And so as I write that down, it makes me recognize again, they're switching places, but this time it's my X value that's changing, or excuse me, the Y value is changing as it switches. So I'm going to move from X, Y to the opposite of the Y times X. And so that's pretty much it. Being able to rotate figures, it's a little bit complicated in terms of trying to memorize the rule, which is why I highly suggest that if you walk away from today's lesson, you shouldn't walk away trying to memorize a rule, but you should walk away with the key point being, can I create this rule for myself whenever I want by just doing this one simple example? Rotate my figure